video, we're going to discuss the steps to conduct a total travel distance analysis to analyze layout. Referring to the previous video, there are many approaches or analyses to determine which layout is better. So here, we're going to use the total travel distance analysis. But how does it work? To conduct this analysis, first you need these four things. The initial layout, currently the layout of the system, how your factory looks like. Subsequently, flow information between all this department. Now when it comes to flow, it could be either a flow between chart or a from to chart. Next, the area or the unit square of each of this department. Here we only have, in this example, we only have 5 departments and all of them have the same size. Lastly, you need to decide what approach to measure distance. So as we mentioned earlier, we're going to pick rectilinear distance. Once you get all those 4 inputs that I mentioned earlier, then we are ready to conduct the total travel distance analysis by conducting this 4 steps. And at the end, we will get the total travel distance of a layout, or sometimes we just simply call it the layout score. Step 1. Fill up all possible department pair. Now what do I mean by this? If the current layout only have 5 departments, then how many different ways can you travel from one department to another department? For example, if you work in department A, where can you go to or where can you travel? Of course, you can travel to department B, to department C, to department D, and department elephant. So department pair basically implies the possible travel from one department to another department. So step 1, fill up all the department pairs. However, how come the department pair of B to A is not listed? If I work at department B, then of course I can travel to A. Now that depends on your flow input. Since the flow input that I use here is flow between chart, which the travel from A to B, and of course from B to A is already added, it's already considered. Hence, I need not to list B to A as a department pair. Why? Because if I use a flow between chart and I list B to A, and at the same time I also have A to B, then I am double counting the flow or the interaction between A and B. However, if instead of a flow between chart and the input is a from to chart, then you need to list out B to A as one of the possible department pair. Now on top of that, you may also notice that all possible department pair also does not include B to B or C to C. Now why? As we discussed earlier on how to collect flow data, this flow or interaction or travel, it needs to be conducted across boundary in the sense that the student need to go over to another building where the observer is at, hence that travel is being observed. However, if the student travel within the department, or in this case A to A, that would not consider as a flow, travel frequency, or interaction. Because of that, you never see A to A, B to B, or C to C as a possible department pair of travel. So once you have filled out all possible department pair for travel, then next, fill up the flow. Again, this number is derived from a flow between chart in the sense that between department B and C, there are 4 persons traveling between them. Is it from B going to C or C going to B? We do not know. And between B and C, 4. And here between B and C, 4. Now the next step, or step number 3, is to fill up the distance in the column. Now this is the most difficult part. Remember, as we discussed in the previous video, when you measure distance, it has to fulfill these three criteria. So what's the distance between department A and B? We go over to the initial layout, which is input to this total travel distance analysis. First, we put the center of the department here, represented by a circle. And then next, we draw lines connecting center to center at the shortest distance. Again, since each department square is same size or in unit square, the length and the width is actually 20 feet times 20 feet. If that's the case, the rectilinear distance, center to center, shortest distance between department A and B is 20 feet. Now you may continue to conduct the process that I've explained to you earlier for all this department. However, I want to focus your attention on the distance between department D and department E. Going back to the current layout or the initial layout, the center of department D is here. The center of department elephant is here. Now, can you guess what is the distance between these two departments? Now, if you guess the distance between the two departments follows the red line, then you are wrong. However, if you guess it's on the black color line, then you are correct. In a sense, what's wrong with the red line? Is it not rectilinear? No, it's rectilinear. Is it not center to center? Yes, it's center to center. The problem with the red line is it does not go through the shortest distance. However, the black line does go through the shortest distance. In a sense, you might ask, hey, Aoyong, are they walking on walls? Yes, they are walking on walls. Why? Because this actually provides the shortest distance. I know, this does not make sense in the real world, but again, right, when you want to do calculation, when you want to do analysis, you have to define, in this case, the distance specifically, so there is no ambiguity. So having said that, you should be able to complete step number 3, which is filling the distance between all these department pairs. Of course, the following step would be just calculation, which is the sum of the flow time distance. Now, once you have the flow and the distance, multiplying them together, then you get this number over here. Add it up together and then you get this number here. Now this number has a special name to it. What do we call them? We call them as the total travel distance. Or sometimes we also call them as layout score. It's just like some people call me Aoyong, some people call me also handsome. It's the same thing. However, what is total travel distance? Of course, total travel distance can be explained in two ways. Mathematically, basically is the distance times the flow for all the departments. That's exactly what you have done in this table. You are following this mathematical formula. However, since we are all OM manager, conceptually, total travel distance basically means that the sum of walk or travel that all your employee need to do in a week or in a day, in a month, depending on your flow time horizon, regardless whichever department they work at, right? They could work at department A, they could work at department B, and also regardless where they are traveling to. So that in itself is total travel distance. Now, having said that, if you are the OM manager or the boss of the system, do you prefer a high total travel distance or a low total travel distance? Going once, going twice, going 3 times. And the answer is you will prefer a low total travel distance. Now why? Basically, a layout that has high total travel distance, basically it implies that your employee that using this layout, they are actually doing more walking or traveling instead of working. Now, some people might claim that a high total travel distance might means that longer travel time or higher travel costs. Now, that might not be true because imagine if you buy this gadget, right, for all your employees, then the travel time might be reduced or the travel cost might be reduced. So what we really can conclude from total travel distance is if it's high, basically in aggregate, after considering all the workers that work in this layout, on aggregate, they travel more instead of working. Now, having said that, in this example, I keep on highlighting that a unit of travel or the unit of flow is your employee going from one department to another department. But in practice, you can apply the same principle, the same approach that we have discussed, right, to another unit of measure. In another sense, you can also apply this on packages which is on conveyor belt or on an individual lift truck. And the last topic in this chapter is determining the total travel distance after switching departments in the layout. Now, when you're designing a new layout for the car factory that we talked about, right? If in the case that you switch department B and department E, so you move this from here to here, again, this is a new layout, right? Then what will be the effect on the total travel distance or the layout score? So the initial layout, which what we have done previously, the layout score or total travel distance is 1250. If you switch these two departments, would the layout score become lower, higher, or the same?